Okay, so chapter 4 is integration. Like I said, it's the last of the things that we're going to talk about. And we're going to start with talking about something called an antiderivative.
Oh, good.
Are you scared of that word already?
No.
It sounds horrible.
It's just the opposite of a derivative.
How do you
Exactly.
It's not horrible, trust me.
It's like,
I wouldn't steer you wrong.
Raise
yeah, but like,
You'll see. Okay, so you should be able to, and a lot of this isn't going to make any sense, but since I do this every time, I thought I'd go over that with you. Like, you don't know what a differential equation is, but we'll get to that eventually. We're going to look for a general solution. We're also going to talk about indefinite integral notation for antiderivatives. That's just scary in itself. You're going to come up with some basic integration techniques so that you know how to do this stuff. And then we're also going to talk about the particular solution. So notice the first one is a general solution. The second one is a particular solution, which we'll get to later. You're fine. Okay, so we'll start with an antiderivative. Simple question. I have a function. That function is f of x equals 3x squared. The question is, Eric, what function can I use that when I take the derivative of that function, I'll get 3x squared? Eric? X cubed. Very good. How do we know you're right? Take the derivative of x cubed. Do we get 3x squared? Excellent. Okay. Any problems there? That process that we just went through is what an antiderivative is. So notice I've introduced a new variable, capital F. Already at this point we have lowercase f, f prime, and f double prime. So if we go in order now, capital F is the function whose derivative gets you to f. So if we go in order, we would go capital F, f, f prime, f double prime. If we go backwards, which is what integrals or antiderivatives do, we go f double prime, f capital F. Okay. So like you said, we would get 3x squared. Any other possibilities? Are there any other functions that when I take the derivative, I get 3x squared? Any?
It could be 3x cubed plus any constant because if the constant it becomes 0. So like,
Give me an example.
so like x cubed plus 7, something like that.
I'm sorry, did you just say x cubed plus 7?
Huh?
Well, that's
Yeah,
weird.
like.
Okay, just for
Like
giggles,
powers.
if you get this right, I'm leaving. Could you give me another example, please?
X cubed plus 4?
Oh, thank God.
Okay.
How about x cubed minus 12? Okay. That was just freaky, I'm sorry.
That was.
So everybody understands the situation here, right? If we did the x cubed like Eric talked about, it's fine. The derivative of x cubed is 3x squared. But then we have all these other possibilities. Anything with a constant, because what's the derivative of a constant? 0, so it disappears. Which means that there's no one particular solution. We have what's called a general solution, or actually we have what's called a family of solutions. And it looks something like that. It's a family of antiderivatives, a family of integrals, a family of solutions. It's a whole bunch of infinite number of things that satisfy the condition. So how do we represent that? We're obviously not going to list all the possibilities, because there are an infinite number of possibilities. Just stick any number plus or minus at the end of the function, and you get another derivative, or get another antiderivative, I mean. So to represent it, we have a new variable, which is a capital C. Am I going too fast?
No, just go back.
Sure. There you go.
Okay, yeah.
Good?
Yeah.
Everybody else good? Okay. So capital C. That capital C is called a constant of integration. It's really, really important. It's the single biggest thing that people make a mistake on with integrals. Some of these integrals and antiderivatives that we're going to do are going to get really nasty. That doesn't cause a lot of problems for people. What causes problems for people is they forget to add a plus C. Or they add a plus C when they're not supposed to. And we'll talk about when you're supposed to and when you're not supposed to. For all the stuff we're doing now, you're supposed to. Now, the weird thing about the plus C is a constant. So what happens if you add two constants together? What is c plus c?
2c.
You would think it would be 2c, correct?
But I'm assuming that's wrong.
It is wrong. Let's suppose I have two functions. Let's say f of x is, we'll use this one up here. No, we'll use this capital F of x is x squared plus c. And we'll call capital G of x 3x squared plus c. If I add those two functions together, if I take f of x plus g of x, I would get x squared plus 3x squared is 4x squared, and you would think you would get plus 2c, but it's actually just plus c. There's pretty much not anything you can do to the c to change it. 2 times c, c. C squared, c. C minus c, you would think would be 0. It's not, it's just c. Because remember, c represents all possible constants. It could be a 7, it could be a negative 12, it could be pi, it could be p, it could be anything. Question?
So what you're saying is, even if it says like 3c or 2c, it's just the same thing?
And it won't say 3c or 2c.
So it won't, and that's why.
Correct.
Okay.
Yeah. Because again, it's just a constant. So even if we know that c is 2,
Yeah, I get it.
3 times 2 is just another constant. Okay. So let's do this. Or let's not. What are we doing?
Harlem Shake.
Remember when that thing popped up?
That thing?
No.
Oh, thanks. Thanks for bringing that up, Abby.
I missed that. What was it? That was funny. What was it?
Oh my god, what was it?
Is it still, was it on video?
I don't know what just happened. It's a good thing I saved the recording for today.
Yeah.
Cancel. Okay, now we are back where we started. I can cut that out. Instead of starting with f or capital F or f prime, I decided to start with y prime. So what's the antiderivative of y prime?
Why?
Y, correct. If I go backwards from y prime, I'll get to y. So what's the antiderivative of y prime, Luke?
2x plus c.
Beautiful. 2x plus c. Any problems there?
Oh.
Good, so we get the family of solutions there, 2x plus c. Because we want a general solution, and there are an infinite number of general solutions. Hey, Luke, if I was to graph all of those possible solutions, what would it look like?
The graph would be lines everywhere.
Be more specific.
Like the 2x and then all along the y and stuff.
Good. Yeah, it would just be the function slid up and down. Question?
Can you take an antiderivative of a double prime prime and just the original function, or is it?
You can take an antiderivative of anything.
Okay.
Yeah. Most commonly, we're going to look at the antiderivative of a double prime, a prime, and a function. We seldomly, if ever, take the antiderivative of a capital F, because we don't really want to go that much further back.
Okay.
Okay, so now we got some notation. Got a new symbol for you today, which is this squiggly thing. I found out 4th period it doesn't have a name. It's just called the integration symbol, which is kind of disappointed. I was hoping it would have a special name.
You could name it, yeah.
What would you like to name it?
Jeff.
Steve.
Jeff. I like that. Very neutral.
Jeff Weekend.
Jeff. So if we take Jeff of f of x dx, we get capital F of x plus c. The thing that you're taking the antiderivative of is called the integrand. In other words, the thing that you're taking the integral of is called the integrand. The dx is very important. That's the second most common mistake that people make, is they forget the dx. The reason that dx is there is it's telling you what's the variable. That dx, by the way, is called the variable of integration. Here it's pretty obvious. We have a function with respect to x, so everything's going to be in terms of x. And that's what we're going to do 99% of the time. But if there are more than one variable, if there is more than one, if there is more than one, then the dx will tell you which one you treat as the variable and which one you treat as constants. Capital F of x is the antiderivative of f, and then c is the constant of integration. So those are all the parts that fit together. Question?
How should we draw this symbol?
I draw it kind of like a stretched out S. It's going to take some practice. Some of you are not going to be able to draw it ever. Others of you will master the skill right away.
It's
So-
the natural talent.
It's like a what is that they call it? A treble clef?
No, it's not like a
Yeah,
treble
but
clef.
that's
It's not.
That's,
Triple
yeah,
clef.
'cause that's trouble clef.
It's like part of a treble
Well,
clef.
I guess it's like
It's
half, but
half.
you'd have to like keep going.
It's like before you did that really far.
Some of you will do this. Some of you will do this. Some of you will make it fatter on the bottom. It'll
That's
just
what my coordinate rest.
it'll just be a train wreck.
I'll just look at it.
But practice makes perfect.
So just type.
So another terminology, this process is called taking an antiderivative. What we're finding when we take the antiderivative is something called an indefinite integral. Taking an antiderivative and taking the integral are the same thing. I worked in the word synonymous there. Means the same thing. It's called an indefinite integral because we're going to get another function. Later on we'll talk about definite integrals. They're something completely different. And I don't want to say anything to confuse you there. Okay, we good? All right, so some terminology then. We got the terminology out of the way. It's called taking an antiderivative, taking an integral. We start with an integrand. We end up with the antiderivative. Don't forget the constant of integration, all those fun words wrapped in together. But let's look at this. I've got a function, and that function is defined as the integral of a derivative. So instead of thinking about integrals and derivatives, think about square roots and squares. What happens when you take the square root of a squared function?
It's just a function.
It cancels. It goes back to itself. What happens when you add and subtract the same number to something you start with? They cancel. So these are opposite functions. I take a derivative, and I take the integral of it, and I get back to where I started. Does that make sense? Okay, good. Now, explain this one to me. Why is it then, if I take the derivative second, where'd the c go? Why is there no plus c on the end of the bottom one?
I hate it.
Because they should undo each other, right? If I take the derivative of the antiderivative, I get back to the original function. But why isn't there a plus c?
C disappeared when you took the derivative, and then, I don't know why it's not there.
Perfect. Why did it disappear though?
Because it's a
Because when
constant.
it's zero.
Beautiful. It's a constant, and the derivative of a constant is 0.
Uh-huh.
So let's break each of these down.
And I was like,
I take the derivative of a function, and I get some other function. I'm doing that first. Then I take the antiderivative. When I take the antiderivative, I'll get another function, but I have to stick a plus c on there because there's a family of solutions. This one takes a function and takes the antiderivative. It'll be some function, capital F, plus c. The derivative of capital F is f of x, but the derivative of a constant, it goes to 0, and that disappears. Okay. That's a common thing that pops up there. One of them has to have a plus c, one of them does not. Becky.
So which one is the general solution? Does the general solution have the f prime of x?
The
Or-
general solution has the plus c on it.
Right, but I mean, so on the other slide, I don't remember there being like an f prime, is there supposed to be an f prime?
Don't get bogged down into the notation, because we're going to be taking antiderivatives and derivatives of all kinds of functions. So it's not necessarily always going from f to capital F. It could be, let's say for instance we start with f double prime.
I know what you're
What's the
saying.
antiderivative of f double prime? F prime plus c. So if you start with f prime, you take the antiderivative of f prime, you get back to f of x plus c. So, and then we can go either way with that. So what I don't want you to do is focus on, well, if I take the antiderivative, I have to get this. It's just notation. It doesn't matter what you call it. It's just a matter of taking the derivative, going to the right, or taking the antiderivative, going backwards. Question first.
If you take the antiderivative, you always have to put the plus c.
Yes,
And then with the derivative, you don't.
correct.
Okay.
And what's going to cause the biggest problems for most of you is not necessarily how to do this stuff. You'll see that the process for taking an antiderivative for basic polynomial functions, which is what we're going to do today, is pretty simple. Right now your brain is dealing with, part of your brain has had derivatives burned into it, so you know to take the derivative, you bring the exponent down, subtract 1, and you do that all over again, over and over again, and you take a test on it, and you're done. Now we're moving the integrals. Now it's a different process, which we'll get to in a second. On top of that, you got to remember to stick a plus c on the end of it. So what's going to happen is later on I'm going to ask you to take derivatives, and for some bizarre reason you're going to stick a plus c on it. It happens. It happens all the time. Or you're going to take an antiderivative and you're going to forget the plus c. Or you're going to take an antiderivative and you're going to do it as if you're taking a derivative by bringing the power down and reducing it by 1.
No, I'll put in my.
No problem. So today's homework is just a basic practice on how to do these integration things, but we need a rule on how that works. So let's suppose I've got this function. We'll go back to x cubed. And I want to know what's the antiderivative of x cubed. In other words, what function, when I take the derivative of it, will give me x cubed? Angela, what do you got?
Would that be, I don't know.
Try. The worst that could happen is you're wrong.
Yeah. I know you need a plus C. I got that right.
Good. Yes. You are correct. So at least partial credit here.
Sweet. I know you have to raise the power up to, like, it'd be something.
Excellent.
Right?
Partial credit's looking even better.
Sweet.
So what should be the degree of the antiderivative of a cubic function?
Would it be the fourth?
The fourth power. Good.
But you need, wouldn't there be
Ah,
a coefficient?
therein lies the key. What is that coefficient? Shh.
1/4.
1/4.
Hey.
Great. Do you know why other than you just heard them all say it?
Because when it would cancel when you like multiply.
Good. I just turned up the volume. I don't know why.
Extra impact.
This class is cursed. 1/4 x to the 4th, which I neglected to include the plus c. My bad. Okay, does that make sense to everybody?
Yeah.
How do we check to make sure it's correct? Take the derivative. If I take the derivative of that, do I end up with x cubed?
Yeah.
Yes, I'm good to go. What if I have x to the nth? What if it's just some plain old polynomial and we don't know that it's cubed, or we don't know that it's raised to the 7th power? It's just n. How do I take the antiderivative of something to the nth power, John?
1/nth x to the nth plus c.
Say that again.
The antiderivative of x to the nth
Yes, is correct.
would be 1/n times x to the nth plus c.
No. Kirsten?
And his same thing that he said, but n minus 1.
Nope. Abby?
That's what I was gonna say.
Are you saying it?
And
Yeah,
plus
okay.
1.
I mean plus 1.
So you're saying plus 1
No, minus 1.
It is
And
minus 1.
minus 1.
and minus 1.
Yeah, that's what I thought.
It's 1
Plus
and 1 over n x to the n minus 1.
What you just told me is the power rule from derivatives.
Yeah.
We want to be able to go the other way though.
Oh, you're talking about anti.
Antiderivatives, correct. Yeah, you gave me the derivative rule, no problem, but I want to know the antiderivative.
Oh. Didn't we, isn't that exactly what we just?
Right.
1 over n times x to the n. Is this the same number?
No. Matt?
1 over n plus 1 times x to the n plus 1 plus c.
Solid, nicely done. You want that in English?
No.
Raise the exponent by 1, multiply by the reciprocal of that new exponent. So if we have x cubed, as Angela says, raise it by 1. She knew it was x to the 4th. She had trouble finding the coefficient. How do you find that coefficient? You take the new number, which was 4, and multiply by its reciprocal. This in itself is not difficult, but like I mentioned, your brain now is going to be battling out derivatives versus antiderivatives and trying to keep them squared away in your head. Do I subtract one from the exponent? Do I add one to the exponent? Do I bring that exponent down, or do I multiply by the reciprocal? It's going to get confusing. Okay, we good?
Yeah.
It's flashing, so it must be important. You will be happy, however, to hear there's no product rule, there's no quotient rule, and there's no chain rule for integrals.
Oh,
Isn't that nice?
yeah.
No catch. No catch. I mean, and it's important because it flashes. But there is no product rule, quotient rule, or chain rule. Unfortunately, this isn't the catch. Unfortunately, some of you will still try it. You'll make up your own rules. You'll try the product rule, you'll try the quotient rule, you'll try the chain rule. Either because you forget, or because you have no other idea what to do, so you just start making stuff up, which I would encourage 100%. Worst that could happen is you get it wrong. It's better than leaving it blank. We're going to have to come up with some ways, though, to work around that later on. We still want to be able to take the integral of something like x squared times the sine of x. But that's a long way away.
Okay.
And it's not nearly as bad as the product rule, the quotient rule, and the chain rule. Okay? There's some trig functions up there. There are 6 of them. And notice the 6 are not the standard sine, cosine, cosecant, secant, tangent, cotangent. They are some bizarrenesses. You'll notice the right-hand side of all those equations are your 6 standard trig functions. So all that is the derivatives of those 6 standard trig functions backwards. So a common mistake that people make with this, I just want to focus on the first 2. Common mistake that people make is they always get this confused. Not necessarily that the antiderivative of cosine is sine, but where to put the minus sign. So I'm going to show you this that a professor of mine showed me, and it's possibly the dumbest thing I will ever teach you.
Is it dumber than if the bottom is heavy, or the top is heavy, the line is steady?
That's not mine.
I know, but.
But yes, it's dumber than that,
Okay.
believe it or not.
That's pretty smart, I still use it.
Yeah. So this is dumb.
Yeah, this
But
is-
it might help you remember where the minus sign goes. Okay? So let's take the antiderivative of the sine of x. And I remembered my dx there. So I could never remember where the minus sign was, so a professor of mine showed me this. He turned the integral symbol into a golf club
Okay.
and turned the dot in this, like I said, I'm not proud of this. But if it helps you,
Oh my god.
great. So turn the integral symbol into a golf club, turn the dot in the sign into the golf ball. And if you've ever seen anybody hit a golf ball off the tee, it moves so fast you can't follow it, right? It moves so fast it just looks like a blur.
Maybe you knocked the tee over.
Don't confuse anybody. Okay. Notice cosine doesn't have a golf ball in it. And you can't use the O as the golf ball because it won't get out of there. It's got to be up on top. Okay? So you get something like this. Again, if you want to use it, great. If you don't, then just memorize the fact that the antiderivative of sine is negative cosine. The antiderivative of cosine is sine. And then these puppies, like I said, are just the backwards antiderivative of the derivatives we learned a while ago. Yeah.
So the derivative of negative cosine is sine.
Correct. Because the derivative of cosine is negative sine. The negative of a negative is, or the opposite of a negative is positive.
Oh boy.
Other than the golf ball thing, I have nothing else, no other clever ways to remember that, other than you know those already. It's just the derivatives going the other direction. Okay, should we try this?
Yeah.
Still writing? Are we good?
Yeah, I'm good.
Okay. Take the antiderivative of that function. So notice I didn't label the function, I didn't give it a name, I didn't tell you it's f of x or y or anything else. I'm just giving you the function. Just tell me what the antiderivative of that function is.
You got rulers on your sons.
Not accurate though. I had to check they're accurate.
Oh. Did your money back then?
No.
Still sucks.
I don't know, what'd you get?
Grant you. You got something a little bit different.
What's the form?
I'm not sure.
Find the, oh, because there's no, it says derivative of sine.
Okay, we got it?
Cosine.
First question, did you remember the plus c?
Yes.
If you didn't, write it in quickly and just say yes so nobody knows. What's the antiderivative of an 8x cubed?
2x to the 4th.
2x to the 4th. Explain that, Becky.
So, because in order, once you take the derivative, you get 8, so it would have to be, and you raise the power above, up 1, so it'd be 4, so 4 times 2 is 8, and so you have 2 in the coefficient and 4 in the.
You have a lot more complicated.
Yeah, that's so too.
Explain it. just
Anybody
go.
follow that?
Yeah.
Okay. Okay, that's fine. That's my bad. What's a derivative of 7 sine x, Jackie?
Negative 7 cosine x plus c.
Plus c. Very good. Okay, so now what I'll show you here is the way that you're not going to do it. You're going to do it just the way we did it. You'll get comfortable with the basic integration rules. You'll go right to 2x to the 4th minus 7 cosine x plus c. But I broke it down by the individual parts. So notice the things that we did with derivatives initially, it's the same thing we're doing it with integrals. So the integral of a sum is the sum of the integrals. Split it into 2 different integrals. Notice they each get their own dx's. Completely irrelevant because you're not going to do that. Then I move the constants out in front. The derivative of a constant times a function is the constant times the derivative or antiderivative of the function. And then I just took the antiderivative of each of those puppies. Any problems there? Pretty straightforward?
Yeah.
Okay, good. Let's move on then. When we took derivatives, we used a basic approach that you did it so much that you didn't even realize. The same thing is true with integrals. You're going to follow this 4-step process. Look at the original integral. You're going to rewrite it into a function that you can work with. You'll take the integral, also known as the antiderivative, then you'll simplify it. So what does that mean? That means if you have, let's say, an original integral that's got a negative exponent in it, or it doesn't have a negative exponent in it, you might want to write it as a negative exponent. For instance, that guy. I'm not going to do anything to 12x to the 4th to rewrite it. It doesn't need to be changed, but I'm going to change 5 times the cubic root of x into what form, John?
Which John?
You, John. John B.
5x over 5x to the 1/3.
Good, 5x to the 1/3. And then how would I rewrite 1 over x to the 5th, Mitch?
X to the negative.
Perfect, okay? Now integrate that. Go ahead, I'll wait. I'm going to talk while you're integrating. The last part about simplifying, remember we get back to our 2 basic rules. No fractions within fractions, no negative exponents. There is a common mistake that happens in a problem like this, and assuming that you're not one of the people that makes the mistake, you're gonna be amazed at how simple the mistake is. That statement made no sense, but you'll understand it. So is it okay if I wait until 12:01 to ship? I don't want to be seen as a
Are you actually going to?
I've committed 30 days to this, I'm not gonna give up at.
Shave a little bit every
Why?
Like shave it during class.
You know how much that would hurt?
That sounds so unsanitary.
Yeah, would that be gross, just like hair line or do it out the window? Okay, I'll hang out the window just for your view. What's wrong?
Do that during don't shave on the summer?
No, I didn't know there was such a thing.
Yeah.
Then there's no shave, you have hair.
After like 1 month, people just get lazy. And then they're like, I should do that. Like, it's at 12. They're like, just don't shave. January.
She says January. Olivia, what do you got?
I started with 12/5 x to the 5th.
How do we feel about the first part?
Yeah.
Solid, good. Raise the exponent by 1 is 5, multiplied by the reciprocal, 12 times 1/5 is 12/5. Excellent. You don't sound so good about the second one.
No.
Did the wheels on the bus fall off?
Yeah.
I almost saying, go wrong.
I know. Yeah.
Skylar, what do you got for the second one then?
I blew a tire as well.
I'm sorry, you what?
I blew a tire.
Blue tire also, okay. Good. Let's work our way down the row. Abby, you got the second one?
I got negative 15/4 x raised to the 4/3.
Can we write this?
Negative 15 force x to the 4/3.
Yeah.
That's what I got.
That's pretty solid. Good. You want to keep going, Abby?
Yeah.
Go ahead.
Minus 1/4x raised to the 4th.
Well done. I will write that down for those of you that are visual learners. John has a question.
But if it's x to the -5th and you subtract 1, wouldn't it be -6? Yeah.
You're correct.
So
Your
it'd be-
statement is accurate.
you have
But
to
we're doing
add one.
integrals, so you have to add one.
Yeah.
That's the single most common mistake. How many of you had x to the 6th?
No, I-
Yeah, okay. Okay, so this was the antiderivative of 12x to the 4th minus 5x to the 1/3 plus x to the -5th dx. Leave that in parentheses. All right, I'm going to bring this up here. So, Olivia, you said 12/5 x to the 5th. Well done. Okay, 1/3 plus 1 is 4/3. Multiplied by the reciprocal of 4/3, which is 3/4. 3/4 times -5 is -15/4. And here's where people make mistakes all the time. -5 plus 1 is -4, not -6. So x to the -4th times the reciprocal, which would be -1/4. And then clean it up.
Plus C.
Yep, thank you. Plus C, good. 12/5 x to the 5th minus 15/4 x to the 4/3 minus 1/4 x to the 4th plus C. And there's our final answer. No fractions within fractions, no negative exponents. Not so bad? It's just going to take practice. You just have to remember the rule. Like I said, the rule itself is not difficult. None of these are that difficult if you remember the rule and your brain stops battling with derivatives. Okay, so you don't continue to subtract one, you have to start adding one now.
Can you leave that up for a second?
Sure. Good? Everybody else good?
Yep.
We're done. Now that's not all of 4.1, that's the first half of 4.1, but like I said, I just want you to practice basic integration techniques. Tomorrow we'll go into more in-depth stuff, we'll have a little bit more theory tomorrow, and we'll actually define that term differential equations that you saw in some of the verbiage that I had on the previous slides. Okay? Day 1 on your assignment sheet for para mañana in Spanish.